Hello, let's begin our study of inorganic chemistry by looking at the very first element, which is hydrogen. Okay, hydrogen is one of the most important elements as far as human life is concerned, and this is because we can find hydrogen inside the sun and stars, which is vital for life on Earth. Also, important organic compounds such as proteins and carbohydrates also contain hydrogen. And overall, hydrogen makes up about 1% of the Earth's crust. Okay, hydrogen makes up about 1% of the Earth's crust. Now, hydrogen exists in different forms, which we refer to as isotopes. Okay, so hydrogen has isotopes. The first isotope of hydrogen is protium. And usually when we say hydrogen, we usually just refer to protium. So protium has the symbol 11H. So protium has one electron and one proton. Protium has no neutrons, and this is very important. Proton has no neutrons. It only has a proton and an electron. The second isotope of hydrogen is called deuterium or heavy hydrogen. Okay, and the symbol for deuterium is 21D. And then the third isotope of hydrogen is tritium or radioactive hydrogen, and represent it with 31T. Okay, so hydrogen is one of the most important elements for life on Earth because it makes up the sun and stars, which we need for energy and photosynthesis. And then building blocks of life, such as amino acids and carbohydrates, also contain hydrogen. Then overall, hydrogen makes up about 1% of the Earth's crust. Hydrogen exists in three flavors. There's protium, which contains no neutrons and is usually implied when we say hydrogen. Then there's deuterium or heavy hydrogen, and then there's tritium or radioactive hydrogen. Let's look at physical properties of hydrogen. Okay, and by physical properties, we mean those things that do not involve chemical reactions, properties of hydrogen that do not have to do with carrying out chemical reactions. And the very first one is that hydrogen is tasteless, colorless, and odorless. Hydrogen has no smell. Hydrogen has no color. Hydrogen is 14.4 times less dense than air. In fact, hydrogen is the lightest element or gas. Hydrogen is the lightest element or gas. Hydrogen does not affect litmus. In other words, if you put in a blue litmus paper into a jar containing hydrogen, it will remain blue. And if you put in red, it will remain red. Okay, it doesn't turn blue litmus red or red litmus blue. Hydrogen does not support combustion. Hydrogen does not support combustion. In other words, you can't use hydrogen to start a fire the way you do for oxygen or like your cooking gas. You cannot use hydrogen by itself to start a fire. However, hydrogen is combustible, meaning you can set hydrogen on fire. You can use another gas such as oxygen to set hydrogen on fire. Think of it like a piece of paper. A piece of paper by itself will not start a fire. but you can set that piece of paper on fire. Okay. And then number 5, hydrogen is relatively insoluble in water. In fact, we usually just say hydrogen is insoluble in water. Hydrogen does not really dissolve well in water. Okay. Now let's see the chemical properties of hydrogen. This will involve some chemical reactions. So I will advise you have your notes with you. Now first, when hydrogen reacts with other elements, what is formed is called a hydride. Whenever hydrogen reacts with other elements, what is formed is called a hydride. Okay. Now, these hydrides can be of the following types. We could have ionic hydrides. Okay. And ionic hydrides are formed when hydrogen reacts with metals such as sodium, calcium, and magnesium, basically metals, especially the alkali metals. Okay, so we could have sodium, which is a solid, reacting with hydrogen, which is a gas, and we are going to have sodium hydride. Okay, we are going to have sodium hydride. So this is an example of an ionic hydride. Okay, we could also have covalent hydride. We could also have covalent hydride. And we get covalent hydride where hydrogen is reacting with non-metals. Okay, hydrogen is reacting with non-metals such as nitrogen, oxygen, and chlorine. Okay, so let's see. I can have nitrogen reacting with hydrogen. They are both gases. And then I'm going to create a compound called ammonia. So there you have it. Ammonia is a hydride of nitrogen, meaning ammonia is formed when nitrogen reacts with hydrogen. We could also have O2 plus H2 to give us H2O. Wow, so water is also a hydride of oxygen. Water is a hydride of oxygen. So you can pause the video and put down these reactions in your notes. Okay, in your notes. We have seen ionic hydride where hydrogen is reacting with metals, especially the alkali metals. We have seen the covalent hydride where hydrogen is reacting with non-metals. And interestingly, we have seen that ammonia and water are actually hydrides. So I'm going to go ahead and erase a part of this so that we look at something we call complex hydrides. Okay, there's something we call complex hydrides. Okay, a complex hydride. So we have seen ionic, we have seen covalent. Now we are looking at complex. A complex hydride usually has a coordinating atom. A complex hydride usually has a coordinating atom which holds hydrogen and another element. Okay, a complex hydride has a coordinating atom, and that coordinating atom or that coordinator holds usually more than one hydrogen and another element. A popular complex hydride is lithium, lithium tetra hydrido aluminate 3. Okay, the formula is LiAlH4, lithium aluminum tetrahydrido aluminate 3. So in this compound, aluminum is the coordinator. Okay, aluminum is the coordinator. And this compound is a common reducing agent in organic chemistry. Another complex hydride is sodium tetrahydrido borate 3, which is NaBH4. And again, the coordinator is boron. Okay, so what have I said so far? Hydrogen reacts with other elements to create something we call a hydride. We have seen ionic hydrides, we have seen covalent hydrides, and what we just saw now is complex hydride. Now, still under the chemical properties, the last thing I would like to mention is that hydrogen is a strong reducing agent. Hydrogen is a strong reducing agent. Hydrogen is a strong reducing agent. And what this means is that hydrogen has the ability to remove oxygen from compounds. So let's say we have CuO. When I react it with hydrogen, H2, hydrogen is going to pull the oxygen from CuO to form water, and then we'll just be left with copper. So hydrogen in this case is behaving as a reducing agent. Okay, feel free to pause the video at any point just to get your notes together. Now, how do we prepare hydrogen in the lab? There are 3 ways, 3 common ways of preparing hydrogen in the lab. The first method is to react zinc and mineral acid. And the acid we normally use is the hydrochloric acid. So when I take zinc and I bring hydrochloric acid, I'm going to end up with zinc chloride and hydrogen. and this is what I want. Okay, so to balance this up, I'm going to put a 2 here. So what has actually happened here is that zinc displaced hydrogen from here. Okay, so this is a displacement reaction. Zinc displaced hydrogen and then stayed with the chlorine to form zinc chloride, and then we have hydrogen. Another method which I won't advise without supervision is to react sodium with cold water. Okay, actually, only about 3 metals can react with cold water. Okay, we have only 3 metals that can react with cold water to produce hydrogen. Those 3 metals are sodium, potassium, and calcium. These are the only 3 metals that can react with cold water to produce hydrogen. Now, let's see if I have sodium and I have cold water. So sodium is a solid. I usually omit writing the state. This will give me NaOH, okay, plus H2. So once again, I have my hydrogen. And to balance this up, I think I should put a 2 here. So I can put a 2 here. And so I can put a 2 here. Okay? So this is the second method for producing hydrogen in the lab. I won't advise it because this reaction can be very vigorous or violent. Okay? I did prefer you stick with zinc and mineral acid. The third method of preparing hydrogen in the lab is to react iron and steam. Now, aside iron, other elements that can react with steam to produce hydrogen, other metals that can react with steam to produce hydrogen, we have magnesium, we have aluminum, we have zinc. Okay? Other elements that can react with cold water, I mentioned potassium and calcium. We already used sodium. Then, if you want to react with steam, you can use magnesium, aluminum, or zinc. So, if I have iron here and I react it with H2O, so this steam, this is a gas, I'm going to create an oxide of iron, Fe2O3. Fe2O3. Okay, no. I'm going to create Fe3O4. Fe3O4 plus H2. And to balance that, I think I should put a 4 here because of this 4 oxygen. And then I'll have a 3 here. So there you have it. 3 ways of preparing hydrogen in the lab. Reaction between zinc and mineral acids. Reacting sodium with cold water. If you don't use sodium, you can use potassium or calcium. Reacting iron with steam. If you don't use iron, you can use magnesium, aluminum, or zinc. Then just by the way, we have some elements we have some metals that cannot produce hydrogen. In other words, doesn't matter whether you react them with cold water or steam, they cannot produce hydrogen. We have elements like tin, we have elements like lead, we have elements like copper, we have elements like mercury, We have elements like gold. We have elements like silver. Okay? So these guys cannot produce hydrogen. Doesn't matter if you use steam or cold water or whatever, you are not getting hydrogen from them. Now, how do we produce hydrogen industrially? Okay, so we are looking at industrial preparation of hydrogen. How can I produce hydrogen in large quantities? Industrial preparation talks about large quantities. Now, I can produce hydrogen industrially in three ways. The first method is what we call the burst process. The burst process. And burst process goes through two stages. Stage one is the formation of water gas. And to do that, I will take carbon, which is coke, and then I will pass steam, that's water, but in gaseous form. I will pass steam over it, and then I'm going to have a mixture of two gases, carbon 2 oxide and hydrogen. So it is this combination of carbon 2 oxide and hydrogen together that we call water gas. The combination of carbon 2 oxide and hydrogen is water gas. Now, this reaction is endothermic. The first stage in the burst process is endothermic because we require heat for the reaction to take place. Think about it. We said red hot coke, meaning this carbon needs heat. It needs to be hot. Steam, water that has been heated. Okay? So that's why we say this reaction is endothermic. Another point I want you to take note of is that when you look at water gas, the ratio of carbon 2 oxide to hydrogen is 1:1. And this can come up in an exam. What's the ratio of carbon 2 oxide to hydrogen in water gas? You can see it here. It is 1:1. Now, after producing our water gas, the second stage is to get our hydrogen. And how do we do that? We simply pass steam over this water gas we produce. And we use catalysts such as iron 3 oxide or chromium 3 oxide to make the reaction faster. Okay, so let me show you how the equation will look like. Okay, I will take my water gas CO plus H2, and then let me change the color of my marker. So now I will add water. So I'm using this purple color to show you that I'm just adding water. And then I will produce CO2 plus hydrogen, 2H2. And this is what I'm looking for. Okay? So the second stage, you take the water gas you produce and then you pass steam over it. And then you end up with CO2 and hydrogen. Now, to remove this CO2, because I don't need it, to remove this CO2, I can dissolve the mixture in water. And the reason why I can dissolve the mixture in water is because at the beginning, I told you hydrogen is insoluble in water. So if you have a mixture of CO2 and hydrogen, and you dissolve them in water, CO2 dissolves, but hydrogen does not. If you don't want to dissolve them in water, another way to remove CO2 is to use caustic soda, NaOH. So what am I saying in essence? At the final stage, you are going to have CO2 and hydrogen. You need the hydrogen, you don't need the CO2. How do you get rid of the CO2? You either dissolve in water or you use caustic soda. Now, sometimes it is possible that some of this carbon dioxide is unused. That is, sometimes we can have unused carbon dioxide. We can have unused CO. To remove this unused CO, you use an ammonical solution. To remove CO, you use ammonical solution of copper 1 ethanoate. These are likely exam questions. In the Bosch process, to remove unused carbon dioxide, we use ammonical solution of copper 1 ethanoate. Okay? And lastly, remember that in the Bosch process, stage 1 was endothermic. So stage 2 is going to be exothermic, just so that things are balanced. If in the first stage you absorb energy, in the second stage or the final stage, you should give out the energy you absorb. Okay, so that's the Bosch process. Again, feel free to pause the video at any point and make your notes. Now, the second method of preparing hydrogen industrially is by using synthesis gas. And the way we do this is we take methane, that is CH4, is a gas, and then we pass it over steam. We pass it over steam, is a gas again, and it gives us CO plus 3H2, both gases. So again, this combination of carbon dioxide and hydrogen is what we refer to as synthesis gas. Now, what's the difference? Because if you remember, water gas was carbon dioxide and hydrogen. Now, we are seeing carbon dioxide and hydrogen again, and we are calling it synthesis gas. So what's the difference? The difference is in the ratio. For water gas, the ratio of CO to H2 is 1:1. But in synthesis gas, the ratio of CO to H2 is 1:3. CO ratio H2 is 1:3. Okay? So keep that in mind. For synthesis gas, the ratio of carbon dioxide to hydrogen is 1:3. Now, after you have produced your synthesis gas, you can take this synthesis gas, CO plus 3H2, and I'm going to change the color like I did before. so that you remember everything in black here is the synthesis gas. And then I add water, actually steam, and this will give me CO2 plus hydrogen. To balance it, I'll put a 2 here. Okay, and then I'll also put a 2 here. And then I'll also put a 2 here. And then I'll put a 5 here. Okay, so this is what I'm interested in. I'm interested in hydrogen. Again, CO2 can be removed by dissolving in water or by using caustic soda. Now, before we leave this industrial preparation, notice that when I use water gas, I had just 2 moles of hydrogen. When I use water gas, I had just 2 moles of hydrogen. But when I use synthesis gas, I'm getting 5 moles, meaning synthesis gas gives me more hydrogen compared to water gas. Now, aside the Bosch process and the use of synthesis gas, we can also prepare hydrogen from electrolysis. Okay, we can also prepare hydrogen from the electrolysis of acidified water. We'll look at that when we do electrolysis later on. Now, how do we test for hydrogen? Remember, at the beginning we said hydrogen has no taste, no color, no odor. So if there is a gas somewhere and I want to know if it's hydrogen because it doesn't smell and it has no taste and it doesn't affect litmus, how can I find out that gas? Well, you could take a stick of match that is still glowing red. You either use a stick of match or you use a broomstick that is still glowing red from fire. When you insert it into a container that has an unknown gas, it usually burns with a pop sound. And this is very important. Hydrogen burns with a pop sound. Hydrogen burns with a pop sound. To end this topic, let's see the uses of hydrogen. What do we use hydrogen for? Number one, we can use hydrogen to make oxyhydrogen flame. Okay, and we use oxyhydrogen flame to cut metals because it produces large amounts of heat. Okay, we can use hydrogen as rocket fuel. We can use hydrogen to make synthetic petrol in places where you have excess coal. There's a way to combine excess coal and hydrogen to get synthetic petrol. We use hydrogen to fill balloons, although we no longer use it, okay? But hydrogen can be used to fill balloons. And then we use hydrogen to harden vegetable oil into solid parts, okay? And that's how we get our margarine and other large substances. So that's all for hydrogen and its compounds. Do not forget to like, share, and if you have any questions, please drop it in the comment section. We love to hear from you. This is Covenant Science Tutorial, and we wish you all the best. Thank you.